So 3.1 was solve linear systems.
These are examples, right?
Yeah.
Alright.
To go with the notes that you should have watched yesterday. Solve linear systems by graphing.
Oh yeah, do you want us to turn in our notes on Google Classroom? Because there was a...
I did, but the picture's like terrible. After we take it.
As long as I can tell that you have them, that's fine. Just felt like we got to the point where some people weren't watching them, so for a while I'm gonna turn them in. All right, I'm about to start giving you notes that you already have. Okay. I guess the big thing is just to remember if it's exactly one solution, okay, two lines intersect at one point. If it's infinitely many, okay, it's the same line, okay, we call that consistent and dependent. The one solution is the consistent independent one, okay, independent because there's one solution, okay, and then if there's no solution, the lines are parallel, and we call that inconsistent, just for reference. Don't forget that stuff. All right, so start with 4. Graph the linear system and estimate the solution, then check the solution algebraically. Okay, meaning just once you get a solution, plug it back in and make sure it works. So y is equal to 5x plus 2, and y is equal to 3x. So I'm going to put some just like graph lines up here, but you don't have to. I will say with this particular section, it does make it easier if you use graph paper just because it's easier to see your intersection point, but not required. All right, so I'm going to set up to graph this. All right, so the top one, I've got an intercept of 2 and a slope of 5, so up 5 over 1. Or down 5, back 1. And my other line, I have an intercept of 0 and a slope of 3. So up 1, 2, 3 over 1. And then down 1, 2, 3, back 1. All right, so not that my picture's perfect, but our intersection point is down here. And what is that point?
-3,
Backwards.
What?
X first, then Y.
-1. I like that.
-1, -3, okay, and then we're going to take that and we're going to check it in one of those two equations. So I'm going to obviously pick the bottom one because I think it's easier. So -3 is equal to 3 times -1. -3 equals -3. And so I've checked it and it's good. All right. Let's see. 10. Y is equal to -3x minus 13, and -x minus 2y is equal to -4. Okay, the top one is already set for me, but I need to move stuff around for the bottom. So -2y is equal to x minus 4, and then I need to divide by -2, so y is equal to -1/2 x plus 2. So that's my new second equation. So those are my two equations that I'm actually graphing there. Now, just since this goes down so far, I'm going to start it over here. Well, I'm not honestly sure that I've even gone far enough at this point, but we're gonna just try it.
Could we just like do it in like intervals like 2, 4, 6, 8? Well, it's 13, so you would.
I mean, you can, but the problem is finding that intersection point counting by twos can be a little weird.
It'd be harder.
Especially if you have an odd slope. Alright, we're going to try this. Negative 13. Did I go far enough? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, 12, 13. Okay, I did not go far enough, so let's just tack that down. So I'm going to go up 3, back 1 for the negative slope, just because if I have to go any farther down, then there's a problem. And I'm going to go ahead and plot a lot of points just because I don't know where it's going to intersect yet. And then I'll make an attempt to connect them as best as possible. Okay, it's as good as it's gonna get. We're gonna hope that somewhere in that range I have gone far enough. Alright, so then the other one, y is equal to negative 1/2 x plus 2. So intercept at 2. I've got a negative slope again of negative 1/2. I don't really need to go down and over because obviously I think just by visually looking at it, the odds that I'm going to connect down there on the right is pretty slim. So I'm going to go up and back and hopefully that will get me there. And then I could be completely wrong, but more often than not, it's not with a slope like that. They're not going to intersect way down there somewhere. So I'm going to go up 1, back 2. And then hopefully this point here that looks like they're intersecting is right. So what would that point be?
Is that -7 or even? I think I might count. Yeah.
6, I think.
Oh, negative. Okay. Negative
The
6.
y is 6.
It's hard to see
Is
something.
it 5? -6, 5.
1, 2, 3,
It
4,
probably
5.
is
Yeah.
if I have ground.
I don't know. I really did this wrong.
Yeah. Well, and it's kind of hard because the grid lines kind of disappear up here on the screen sometime for some reason. It's hard to see them.
It probably was worse for me because I'm not using graphics. They didn't intersect.
But that's also why we go back and check the point, because then we can verify that we're right.
Yeah.
So I'm going to plug it into the top one. So 5 is equal to -3 times -6 minus 13. So 5 is equal to -3 times -6 is positive 18 minus 13. 5 equals 5, so then shows that it works. Most likely for the quiz or the test, I'll like print off some like graph paper piece for you, unless you have, like, if you don't have your own, I can print one off. Just because I don't want that to be a reason that you get a problem wrong. Like in your homework, if you check it and you're like, I really can't figure out, like, I know that my point's wrong, but I'm not using graph paper, like, it's not a big deal. As long as you understand the principle, then you're good. In worst case, you'll know other methods by the time you take a quiz or a test, and so you can check it using another method, and you can be like, I can't figure out what's wrong with my graph, but according to this other method, this is what it should be. And then also, I typically, like, yes, you have to graph it if I tell you to graph it. But if you use another method because something's not working, I'm typically pretty generous in giving you some kind of credit for at least showing that another method, you found the point if there's a graphing issue. So All right, number 12. Go all the way down here now. Y is equal to 4x plus 3, and then I've got 20x minus 5y is equal to negative 15. So I need to do some stuff with this bottom one. So I'm going to subtract the 20x, so negative 5y is equal to negative 20x minus 15. Need to divide by negative 5, so y is equal to 4x plus 3. What do you notice about that?
There's the same.
The same line, so what does that mean? How many solutions do I have?
One. I mean, many.
Infinite.
Many solutions.
Infinitely many solutions. Okay, and as soon as you see that, I don't even care if you graph it. Okay, with one like that, I don't care if you graph it. If you were to have one that they came up and gave you parallel lines, I am completely okay with you telling me those lines are parallel because they have the same slope and not graphing it as well. So if you see that, if you want to graph it, that's completely fine, but that's another way that, you know, I'm not trying to be obnoxious and make you graph every little thing, you know, so. All right, so then the next problem, say to solve the system, then classify the system as consistent and independent, or consistent and dependent, or inconsistent. With these, we pretty much should be able to look at the lines and tell what they are. I'm okay with you doing them algebraically. Ultimately, we will do them algebraically. Like next section, you'll do them by one of those other methods. So I'm going to go ahead and show you a couple now, but it'll come up again in the next section. So this is just kind of getting you like a little bit of a jump start. You're more than welcome to do them by graphing, but typically if that's all it's asking me for, I would do it algebraically. So, let's see, 18, 2x minus y is equal to 4, and x minus 2y is equal to negative 1. So this one, we can look at it kind of a couple different ways. We can rewrite these in y equals mx plus b and look at the slopes and then kind of have a pretty good idea of what's happening. Or you can go about the other methods if you remember how to do substitution and elimination, and you can do them that way. But let's do the if we were to graph them method. So I'm going to rewrite this line. So that's going to be negative y is equal to negative 2x plus 4. Divide by the negative 1, so y is equal to 2x minus 4. And then this other one, negative 2y is equal to negative x minus 1. Divide by negative 2, y is equal to 1/2 x plus 1/2.
Where's the 1/2 come from?
Dividing by 2, or negative 2. All right, so looking at these, what could you tell me about these lines? Are they the same line?
No.
No. Are they parallel?
No.
So what does that mean it has to be?
Consistent.
Okay, consistent in what?
Dependent, because it should only have one.
So if it only has one, it's independent.
Okay. So
Dependent is infinitely many.
Oh, okay.
I like to think like if you're an independent person, like you like to like do stuff by yourself, so it's like one solution, one person. This is the way I kind of have to remember them because I tend to mix them up. let's look at 20. We've got y is equal to 2x minus 1 and negative 6x plus 3y is equal to negative 3. Okay, if you wanted to do it by substitution and plug the stuff in and see what happens, you absolutely could do that. Another way is just, again, to figure out if the lines are the same. So I'm just going to use that method for right now, since you technically, I mean, yes, you've learned the other methods before, but since that comes in a later section, we're going to see if this will work. So I'm going to add the 6x over, so 3y is equal to 6x minus 3. Then I'm going to divide by 3, so y is equal to 2x minus 1. So what do you notice about these lines?
They are the same.
Okay.
Infinite, so
They're the same, so it's infinitely many solutions. Which means it's what?
dependent.
Okay, consistent and dependent.
Does consistent mean more than one? At least
I don't think,
one?
like,
Is that what consistent?
they like mean the
Consistent is just like,
At least one
it's for
solution.
one or, yeah.
same.
Consistent is for
Will
at least.
consistent only be on parallel lines?
Inconsistent, yeah, is only parallel. Because they never
Independent
intersect
and
anywhere.
Consistent mean like the same thing. In the notes, it says exactly one solution. Well, consistent is at least one solution.
Consistent is at least one solution. Inconsistent is no solution.
I'm in independent, consistent. Independent is exactly one solution, so it can only have one. Consistent is at least one, so
Well,
it can have one.
It would be consistent and independent, or consistent and dependent. It's got to be both. Or it's got to be two of the things.
Well, he was saying that they're the exact same.
No, I was just saying they're basically the same.
They are, but like,
Like if it does have at least one, then they are the same. 'Cause then it has exactly one.
Alright, 22, 4x minus 5y is equal to 0, and 3x minus 5y is equal to negative 5. So I'm going to rewrite them. So negative 5y is equal to negative 4x. And then divide by negative 5, y is equal to 4/5 x. And then the other one, negative 5y is equal to negative 3x minus 5. Divide by negative 5, y is equal to 3/5 x plus 1. So these are the two equations that I'm looking at. So based on that, what do we have?
Consistent. Independent.
Yep, consistent and independent. And then let's just do one more. 28. 5/2 x minus y is equal to negative 4. And 5x minus 2y is equal to 1/4.
disgusting.
That's some devil language.
Alright, so subtract 5/2 x, so negative y is equal to negative 5/2 x minus 4. Divide by the negative, so y is equal to 5/2 x plus 4. And then the other one, negative 2y is equal to negative 5x
Is that 1/4?
plus 1/4, yeah.
So
We
there's
look at 9.
And then divide by negative 2, so y is equal to 5/2 x Okay. Well, it's minus. Negative. So when you divide a fraction by another number, it's the same as multiplying by a fraction. Okay, so multiplying by 1/2 instead of dividing by 2. Okay, it's the same thing. So it would be 1/4 times 1/2, so it would be 1/8. So 1 equation, 2 equations. So what do we notice about these ones?
Parallel, so that would make them inconsistent.
Okay, so there's no solution, so it is inconsistent. Any questions about any of this? All right, I'm not going to give you an obnoxious amount to graph, so your problems are 3, 5, 17, 21, and 23.